Welcome back to 50 computer vision applications for smart cities part 2. Today we will discover 12 new computer vision applications that might bring a city management on a whole new level. We will be all over the places, above the ground, under the ground, and also in the air. Let's start. The sixth application in the series is train or metro platform behavior recognition. We start simple as usual. We have the person detection and tracking, and then use cases can diverge. For a simple use case of people are too close to the border of a platform, we can use simple detection in the zone. But if you want to use some kind of behavior recognition algorithms, we might want to consider either key point detection plus classification or classification of multiple frames of a single person to capture different actions. Another application might be region specific. For example, in France, there is a special badge for the quality of an engine, of a car engine, that is called Crit-Air, and we might want to detect this badge on a windshield of a car. Here we are using detection and tracking of a vehicle plus additional model for badge detection. Another quite similar application to the badge detection is Hazmat number plates recognition. In transportation of different materials, we have a lot of symbols to identify if those materials are explosive, flammable, toxic, or hazardous in any other way. Those plates are looking like that on some kind of heavy truck. We start by detection and tracking those vehicles. Then we might need an algorithm to detect those plates and classify them. Some of the plates might have some additional text. We might want to use OCR model to decipher it. Another classical use case of computer vision is speed measurements from the cameras. As usual, we start from detection and tracking of vehicles. We can identify the path traveled by a single vehicle. The hard part is to calibrate the camera in order to compute the path of a vehicle inside the image to the lens in the real life. And then we can divide the distance by the time to find the speed measurements. The 10th application in the series will concentrate on the cleanliness of our cities. We are trying to detect illegal waste dump. For example, here we have a special zone where we have trash cans, but someone decided to throw the bag not inside but near the trash can. Our goal is to detect these type of objects. 11th application is crash detection. The goal of crash detection is to understand if on the observed image of a CCTV camera we have some anomaly as a crash of two vehicles. We can always start by detection and tracking of different types of vehicles. Additional model that we will need to develop is either collision detection, that will try to predict and detect if the cars will collide, or we can formulate this task as anomaly detection. We will track the trajectory of a car, and if the movement will be too far from the movement model of a car, we might trigger some warnings. Another application in a series of incident detection is a red light crossing detection. So here we can always start by detection and tracking of different vehicles. If we want to understand that vehicle crossed the red light, we would like to know where is traffic light, and also we need some kind of association of a direction and this traffic light. For simple cases, we can hint the algorithm manually with some lines. In more complex use cases, we might need some algorithm to detect the association between traffic light and the direction. And also we need to understand which color is the current traffic light. In many hardware installations, the cameras that are placed on the edge device have direct access to the smart traffic light, so they know the state of the light and the association between the direction and the traffic light. Let's go inside the buildings and try to understand what we can extract from movement heat maps. This application might be very useful in public spaces, museums, malls, and any other buildings with a lot of clients. First, we start by detecting people and tracking them through the building. Then we can build a heat map which will show in which position in the space people tend to spend more time. If we need to go one step further and to answer a question which picture or which statue was observed more often, we can try to add algorithms of head detection and head orientation to make a more detailed analytics. Let's get out of the buildings to understand how many people we have outside. There will be two use cases of crowd counting. First one is a dense crowd counting. We can approach this use case with two models. First one is full body detection, where we try to detect the bounding box around the whole person and count the number of people in the image. But this might be difficult in the dense use case because usually the bodies of the people are occluded. So better precision can be achieved with only head detection and tracking of different heads. A variant of crowd counting might be sparse crowd counting, where bounding box of different people are not occluded by each other. We can start from people detection plus tracking and the zone counting. This use case might vary largely in complexity depending on the point of view. Here, persons are not occluded. Every object is quite small, so we might need to fine-tune model to detect small objects on the image. Going one step further with pedestrian detection, let me introduce pedestrian attribute detection use case. The idea is to start with person detection and tracking, and then add multiple models that will try to understand different attributes of any given pedestrian. Usual use cases are age, gender, upper clothes, bottom clothes, maybe if a person has a backpack or not. 17th use case is analysis of aerial images. We have images from some planes or drones and we want to detect if there were new pools that were built in the area. Starting with aerial imaging that we can obtain from some provider, we want to build a simple detection model that will try to detect if there are different pools. Then we can match those pools with our database of registered pools and find if some pools were constructed and not registered. We can go one step further and try to classify if the state of the pool is clean or dirty. That will help us to create safer environment for our neighbors and the cities. That was the second part of a series 50 computer vision applications for smart cities. If you like, please subscribe to this channel. If you have any questions about any use case introduced here, drop the comment or connect me in the social medias. We will see you in the next part.